Class?
Yes.
All right, we are going to get started on our super duper fun math lesson, okay? So the first thing we'll do, this lesson is broken down into a few different parts. So the first part is we're going to watch this video about
Brownies.
We always say this, I know, but like these are actually the best brownies you're ever going to have. They're gooey, they're chocolatey, they're fudgy. They live up to every expectation you think a brownie should be.
Oh.
We took all the tips and the tricks from the internet, from our old grandma's recipes, from places we've worked to find the best recipe that we could. Throw out every other recipe that you have for brownies. This is the one you will use going forward for the rest of your life. I'm not trying to like toot our own horn, but like beep, you know? Fudginess comes off. They're fudgy, but they're not dense.
Now for some reason I love like the amount of students.
Okay, so we're going to stop there. So now that we've watched this video about brownies, now can you guess what our math problem is going to be about today? Okay, yes, it's going to be about brownies. So first let's talk about brownies a little bit. So what are some things that we could add to brownies to make them even more delicious? What do you guys think? What are some things we could add to our brownies to make them even more yummy? Morgan?
We could add syrup.
Syrup, okay,
And
interesting.
Powdered sugar.
Powdered sugar, okay. Alex?
Honey and sugar.
Okay. Christopher?
Extra chocolate.
Maybe extra chocolate, okay. Sam?
Ice cream.
Oh, you're thinking of like when it's done, what you could serve with it? Ice cream? Yeah, okay. Zachary? Salt and butter. Maybe sprinkles?
The
Yeah.
syrup and the powdered sugar was what?
Extra fudge, yeah.
Like-
Ben?
Hershey's chocolate syrup, powdered sugar, and a maraschino cherry and ice cream.
So you're thinking like a
And
brownie
sprinkles.
sundae. Okay.
Joseph.
You guys one at a time, please. Hold on.
Caramel.
Maybe caramel. Okay, good. One more. Morgan, you already shared. One more?
No, but
Anybody else want to share one more?
The thing that I meant to do was like the thing, like to put it on top. With
Oh, on top, once they're already all baked.
Yeah.
Okay. Okay. So, let's talk about our story for today, our math story. Okay, I want everybody to close their eyes. I want you to picture this. Close your eyes. Okay, we have 6 students. Okay, 6 kids. Close your eyes. I want you to envision this. Maybe they're at, I don't know, maybe they're at their last day of school class party. Maybe, I don't know. And these 6 students are sharing 14 brownies, just like the ones you saw in the video. Each kid is going to get the same amount of brownie. How many brownies will each student get? Okay, so I'm going to repeat that one more time. 6 students are sharing 14 brownies. They each get the same amount. How many brownies does each student get? Any questions? Okay, I'll say it one more time. 6 students are sharing 14 brownies. And it's actually right up there on the whiteboard too, you guys, in case you forget. Okay? 6 students are sharing 14 brownies. Any questions? Okay, I want you to talk at your table groups for a few minutes just about the story problem and write down anything you need to on your paper that might help you solve this problem. Okay?
Easier? Well, I think we should do 6 because there's 6 people.
I think we should do a division
Why division?
because they need to each have equal.
Yes.
Okay.
What's 14 divided by 6?
14 brownies, and then we split them all into, well, we give 6 to other people, and then we split the last 8 into maybe 6. So everyone can get like 1 of each. So they would have 8 sixths and 1 whole.
Why don't you just do this? Just do 14 divided by 6
talking.
whatever.
No, but that's impossible. No, we need to actually, it's a fraction. It's going to be a fraction. Divided by 6. That's impossible. We're getting a whole number.
Okay, class?
Yes.
Quiet signs, please. Thank you. Okay, we're going into our next portion of the lesson, which is going to be your independent solving time. So now, Zachary, are you listening to my directions? Okay. You are going to work by yourself, quietly on your own paper, and you're going to solve. How much brownie will each kid get? If there's 6 kids and there's 14 brownies. Okay, any questions before we start your independent work time? Okay, go ahead and start first.
I do 14.
14 what?
So I minus 2 of them. 14 brownies.
Yeah.
I minus 2 of them and then 12 divided into 2 equals 6. And the second ones, I each divide into thirds to equal 6 since there's 6 kids.
So tell me why you did thirds again?
It's because there's 6 kids and there were 2 left. And 3 times 2 equals 6.
Oh, okay, good. So then how much, and then what is this shaded? Oh, how much, say it again, sorry.
How much each gets?
How much each kid gets, okay. So how much does each kid get?
2 1/3.
I split them into and then
Wait, what do you mean you counted how many?
no, I put how many on and then I put the numbers on and then there was 2 left, so I split them into 6. And I put
Why did you split them into 6?
because there was only 2 left. I didn't know what else.
But how did you know to do sixths?
Because there was 6 kids.
Oh, interesting. Okay, so you passed them all out and then you had 2 left over.
Yeah.
Okay. And then what was your final answer?
2 and 2 6.
Okay, good.
These are, I'm numbering the kids and these are the ones that they're gonna get. Then I'm gonna split these 2 up to make it 6.
So by putting the numbers on here, you're kind of passing out the brownies to the
Yeah.
kids. Okay, good. Keep going. Good job. Okay, so I have a few students whose work I'd like to share. Are you excited to see who it is? Okay. So the first student is our friend JoJo.
Yes.
I knew it.
So I thought Joseph's strategy was really interesting. So I'm gonna just show you. Okay, can you tell me something, Joseph? What's the first thing you drew on your paper?
First thing I drew was the kids.
The kids. And how many kids were there again?
6.
So I'm gonna try to do this a little small so I have room for everybody's. Okay, so we drew 6 kids. And he drew them like little stick figures.
Oh.
How are they supposed to do? They don't have mouths.
And 6. So you drew the kids first. Raise your hand if you also drew kids first. Okay, good. Okay, and then what'd you do?
And then I put 14 brownies in square, like rectangles.
Okay, so you drew your 14 brownies. Yep. Okay. Now wait, let's stop there. What does anybody can anybody guess what you think Joseph did next? What do you think was his next step? What do you think, Zachary?
Drew arrows.
Maybe drew arrows? What do you think?
Partition.
Partition? What do you think?
Partition.
Is that what you did next?
Yeah.
There was-
Partition.
But there was one, it looks like there's one thing you did before you partitioned to the kids.
Oh, I numbered them.
You numbered the kids, which a lot of you guys did, which is a really good strategy. So he wrote a little number on each kid, right? So he numbered them 1 through 6. Why do you think he did that? Why do you think he numbered the kids? Caesar.
He numbered them because it would show which one is.
It would what?
It like he'll know which one is number 1 or 2.
Okay, what do you think?
I think he numbered them so he could number the brown ones.
Oh, so he could number the brownies too. Zachary and Mackenzie, pay attention please, okay? So after he numbered the kids, then he did that thing that we just said. What is it? What's that word again? Starts with a P. Everybody say it?
Partition.
So then he partitioned his brownies. Now, how do you think he partitioned them? Zachary, what do you think?
Like the thirds.
You think he did thirds. He didn't do thirds. What do you think, Blake?
6.
Yeah, so he he partitioned all these up into sixths. And he actually did it like this. So that there were 6 pieces. So he did that all the way. Oops, I did an extra line there, sorry. Ugh. So he did diagonal and then one down like that. There we go. Okay, so he did this to all the brownies,
Which is a lot of brownies.
which is a lot of partitioning, isn't it?
Yeah, but at the same time, it's a lot of brownies.
A lot at the same time, what, Blake?
It's a lot of brownies.
Right. Okay, he did sixths. What did he do next? What do we think? What do you think he did next? He's partitioned them all into sixths. And wait, hold on. Why did he do sixths?
I think
Jack?
Because there's 6 kids.
Because there's 6 kids, okay? So what did he do next? Mackenzie? He numbered them. And what does that mean when he's numbering them? What is, if you can kind of picture it in your mind, like what is he doing by numbering them?
It'll mean that piece goes to that kid.
It means that piece goes to that kid. Awesome job. So he numbered it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Instead of doing all of them, I'm just gonna go like this. I'm just gonna pass out all the pieces to kid 1 first.
Why?
the thing I also did.
I'm just trying to cut down the time a little bit so we have time to share everybody's. Okay, so let's think about kid 1 real quick, okay? So Joseph wrote all the numbers, right? But I just want to think about kid 1. So I need to figure out how many pieces kid 1 is gonna get. So will you guys count with me? 1, 13, 14. So how many pieces of the brownie does each kid get?
14 pieces.
So is 14 my numerator or my denominator?
Numerator.
So the top number, right? And then what's my denominator? Jackson. And how do you get 6? Each brownie's partitioned into 6. So each kid gets 14 sixths brownies.
Wait, what?
So listen, I want you guys to think about. Huh?
I put it in.
Oh, okay. So we'll talk about that next. So when you look at this strategy, it definitely works because each kid gets the same amount. Because if we were to keep doing what we just did with number 1 and we were to keep shading and giving each kid their pieces, we'd get the same amount, right? Each kid gets the 14 over 6, 14 pieces. But if you're doing this in real life, do you feel like this is maybe a little bit too much work? Because you're having to cut each brownie, right? So do you think there's a little bit more of an efficient way of doing it?
Yes.
Instead of cut, I'm not saying it's bad, it's a great way. I'm just saying if you're doing it in real life, you might want to think about what could be a more efficient way of passing out the brownies. So what do you guys think?
That actually took me a long time.
Right, it takes a long time to partition each one, huh?
I have an idea.
Okay, so Ben, what do you think?
Well, at first pass out the brownies by whole, and whichever ones are left, partition them.
Oh, so another strategy could be first to pass out all the whole brownies that you can, and then partition whatever's left. So that brings me to what Emma did. Is it okay that I share yours? Okay. Emma, very similar to Joseph, right? Where she drew her kids. She drew her 6 kids. Is that 6? Yeah. And then she drew the 14 brownies.
And she partitioned it.
I'm gonna show you.
No.
I know, sorry, now I'm drawing big, huh?
The
Okay.
biggest brownies I've seen.
And
Don't have time for more.
The biggest brownies are the best.
did I do too many? No, I did good. Okay. 14 brownies. Okay, now Emma, so instead of partitioning them all right off the bat, she just started passing out the holes, right? So she did the same thing where she numbered the kids. Okay? And then she started numbering these. Right? 6, 1, 2, 3, 4, 5, 6. And then she realized, well, she can't pass out any more holes, right? Because there's only 2 left. So what do we think she did next? What do you think Emma did? After she passed out the holes, so each kid, wait, first, how many does each kid get? How many holes?
2.
Okay, each kid gets 2 holes, okay, right? Because look at kid 1 gets 1 hole and this second hole, right? So now what did she do with these last 2 pieces? What did Emma do? What do you think, Grace? What do you think Emma did to these last 2 leftover holes?
She crossed them out to make them like.
What's that P word we talked about? Do you remember?
Partition.
Yes, good job. So what do you think she did? She partitioned. Hold on, let Grace talk.
Into 4.
You think she did 4s? What do you guys think?
No.
Do you guys think she did 4s?
No.
I mean, what do you think, Emmy?
I think she did it in 6.
You think she did 6? Why do you think 6?
Because there are 6 kids, and if she had 2 left over, they would all get the same amount. So if she did 6, they would each get 2 6.
Yeah.
2
So Emma, do you remember what you did? You did 6, right? Okay, good. So she actually split them like this, and then she did it like this. So she made 6 pieces for each of those holes, okay? And then she did the same thing where she passed these out. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6.
I think
Now,
it's easier than.
how many of these small pieces will each kid get, Jackson? 2, right? Because if you shade the 1 and the 1, right? This is kid 1. Kid 1 is gonna get this one, this one, this one, and this one. We already have our 2 holes, so what's our fraction gonna be then for those 2 other leftover pieces? Christopher, what do you think? What will our fraction be for these 2 pieces that I just shaded?
I'm not even raising my hand.
I know, but I just still wanted to see what you thought. I don't only call on kids who raise their hand. What do you think? Any ideas? If you look here at these squares that we partitioned, can you scoot over a little bit, Zachary, so he can see? What do you think? So what are these partitioned into?
6?
Okay, and how many pieces are shaded?
Only 1.
I'm sorry, all together. How many of these little pieces are shaded? So this piece right here and this piece. How many are there? Is that all together? 2, yeah. So that's our fraction. 2 and,
That's
because
what
then
I,
they get these.
that's what I also put.
Oh, so after you did your 14-6?
14.6. I put 14.6 equals 2 and 2.6.
Okay, that's good. Okay, so this is how Emma did it. Now, I'm gonna show one more real quick. And I think I'm just gonna use my drawing for Emma because Jackson
Did the same thing.
did basically the same thing. However, I'm just gonna write Emma/Jackson to save space. So Jackson drew the 6 kids, he numbered them, he drew the 14 brownies, he passed out all the holes. But what Jackson did different was down here. I'm gonna circle these and write Emma. And then I'm gonna draw it again. I'm gonna draw those 2 leftover brownies again.
Bigger.
This is what Jackson did. So what do we think Jackson did to those 2 leftover brownies? Right, he passed out all the holes. We found out that there was 2 holes for each kid, but then there was 2 brownies left over. What do we think Jackson did with those 2? Who have I not heard from yet? Kira,
In 2 thirds.
you think he did thirds? Why do you think that?
Well, 3, and there's another part of 3 that would equal 6.
Oh, so you're saying if he did thirds, that would make you get 3 pieces here and 3 pieces here, and that's 6 altogether. And then how many kids do we have?
6.
Okay, so yeah, Jackson did.
6.
He did thirds. So Emma did 6, right? Jackson did thirds. So then if you were gonna pass these out, you'd go kid 1, kid 2, kid 3, kid 4, kid 5, kid 6. So how many thirds is each kid gonna get now? 1 third. So what is Jackson's fraction for how much each kid will get? Emily, what is Jackson's fraction for how much brownie each kid will get? 2 and 1/3.
You said 2.
So Emma, 2 and 2/6. Jackson, 2 1/3. Joseph, 14/6. But are these all the same? What do we call that word in math?
Equivalent fraction.
Nice. So these are all equivalent fractions. And so if you look here, 2 1/3 and 2 2/6, you have 1/3 and 2/6. Those are
2/6 makes a
equivalent.
third.
Yeah, good. Awesome. Okay, good job, you guys. Any questions? Yes.
Are we gonna do this again?
Maybe. You like doing this?
Yes.
Okay, good. Yeah.
I did the same thing as Jackson.
You did the same thing as Jackson. Okay, let's take a quick poll. Raise your hand if you did Emma's way. Okay, a couple of you got 2 and 2/6. Raise your hand if you did Jackson's way. Raise your hand if you did Jackson's way. So your answer was 2 1/3. Okay, good. Raise
What
your
if
hand
we
if you
didn't
did
do it-
Joseph's way.
What if we didn't do it the same way? Like we did like a different strategy but not the same.
But you got the same answer? I guess I mean, raise your hand if you got this answer. Raise your hand if you got this answer, yeah. So raise your hand if you got 2 and 2/6. Raise your hand if you got 2 1/3.
Oh,
Raise your hand if you got 14/6. Oh, interesting. Okay, good.
I got a new
It's all
Okay.
equivalent.
They're all equivalent. Good job. Christopher.
Are we gonna do brownies?
Now everybody wants brownies. Okay.